Good evening, students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with another topic of electrical engineering, which is types of transformers. We have already seen what is transformer. It is a static device for converting low voltage at high current to high voltage at low current and vice versa. Okay, so we have already gone through what is the transformer. Now let us see what are the types of transformers. Okay, so they can be categorized in four ways. Four ways we can categorize the transformers. So the first way is according to the type of cooling. The second way is according to the type of structure, then according to the operation and according to the usage. Okay, so in the first type, according to the type of cooling, they can be again divided into oil type and dry type. Oil type transformers and dry type transformers. Okay, then the second category is according to the structure. It is divided into core type transformer and shell type transformer. Okay, and according to the operation, step up and step down. Okay, if we want the voltage on the secondary side to be higher, then we use step up transformer, and in the secondary side, if the voltage we want to be lower than the primary side, then we use step down transformer. Okay, and according to the usage, they are again divided into power domain and electronics domain. In the power domain, they are again divided as power transformer, measurement transformer and distribution transformer. Distribution transformer is for distributing the electricity to our households. For that, the distribution transformer is used. Then measurement transformer is again divided into current transformer and voltage transformer. Okay, then in the electronics domain, the pulse transformer and audio or output transformer. We are not dealing with the electronics domain over here. It is electrical engineering, so we will be dealing with the power domain over here. Okay, so we will be studying all the types step by step in detail. Okay, so today we will be dealing with the transformers according to the type of cooling, which are again divided into oil type transformers and dry type transformers. Okay, so let us start with the oil type transformers. So oil type transformers are again divided into two types: oil filled self cooled and oil filled water cooled. Okay, there are two types of oil filled transformers in which they are categorized into oil filled self cooled and oil filled water cooled. Okay, so in the oil filled self cooled, the assembled windings and the cores of such transformer are mounted in welded oil tight steel tank. Okay, they are mounted in a steel tank and they are welded. Okay, then provided with a steel cover, and also a steel cover is there on the outer side. Okay, when the core is placed in the tank, now when it is welded, welding is done, everything is done, winding is done, the core is being placed in the container, in the tank, we can say the tank. Then the tank is filled with purified high insulating oil. Okay, so when the assembled core, the winding, everything is done with the winding, with the core, and this that is placed in a tank which is also made up of, which is having a steel cover also. It is also having a steel cover. Okay, so when it is placed in a tank, then in that tank high insulating oil is being dropped. Okay, so with purified high insulating oil is being dropped. So in this type of oil filled self cooled, oil insulating oil is the main part, because the whole transformer is being placed in that oil. Okay, then it is used for small and medium distribution transformers only. For large transformers it cannot be used because economically it is not sounded. Okay, economically the cost is very much high, so we cannot use it. So the cooling is self cooled. So because of that oil, the transformer, when it is heated up, it gets cooled because of the oil, insulating oil. That oil is also having an insulating layer, you can say, and so with that insulating layer, insulating oil, the transformer gets cooled. Okay, the second type of transformer in this category is oil filled water cooled. Okay, it is water cooled. So here also the windings are assembled, then the cores and windings are made, and they are not placed in the oil, but there is a cooling coil through which the water is kept circulating near the surface of the oil. Okay, so they are not actually placed in the oil. There is a cooling coil is there through which water is kept circulating. So water is circulating continuously from that cooling coil, and with that cooling effect, the transformer which gets heated, that gets cooled over here. So heat is removed by this water only, and it is used for large transmission purposes. Such type of transformers are used for the large transmission purposes because it is cost effective also, and secondly the oil which has to be put in the oil filled self cooled, that gets reduced, so the quantity gets reduced, so naturally it is cost effective. Okay, and also these both oil filled transformers are used for the outdoor substations, outdoor installations. They're used for the outdoor purposes only. In the society, in the area which is being crowded by much of the people, it is not placed there. It is placed outside, for the outside installations. Such type of oil filled transformers are used. Now let us come to the second category in this, which is dry type transformers. In this type of transformers, no oil is being used anywhere. So it is dry type transformers. So they are again divided into two types: air natural and air blast. So we can say air natural dry type transformer, as well as we can say air blast dry type transformer. So in the air natural, ambient air is used as the coolant. The natural circulation of air is used for dissipation of heat generated natural convection. Okay, so in the air natural air is the only coolant. We are using the natural air, and we are giving lots and lots of air is given in the transformer, so that the transformer is cooled. Okay, gets cooled. So the dissipation of heat generated natural convection. By the natural convection, whatever the heat is generated, that gets dissipated, that gets removed by the means of natural air. So natural air is very much important over here, and it is used in the places where the fire hazard areas are there. Okay, where some if some area is having some oil factory, some oil generation factories there, where kerosene factory, petroleums, where the petroleums are installed, at that places the oil filled transformers cannot be used. It cannot be used. Only at that places air natural transformers can be installed, because of the oil, it may easily catch fire, electricity and oil, and if any spark is being made, or by mistake any spark comes, or any short circuit comes in the transformer, then the area may catch the fire. Okay, so every area that is fire hazard areas, adopted in the fire hazard areas, so where the fire can easily catch, so at those areas the air natural transformers are used. Okay, and it is used for the rating for 1.5 MVA to 3 MVA. So such type of transformers are used for the rating of 1.5 MVA to 3 MVA. Okay, now let us move on to the air blast transformers. In the air blast transformers, core and windings are not immersed in oil but housed in thin sheet metal box which is open at both the ends, through which the air is blown from bottom to the top by fan blower. Okay, so in this type of transformer, what is actually taking place? They are not immersed in any of the oil, and they are not immersed in any of the water. So what is being done? They are housed in thin sheet metal box. So they are housed in a metal box. Metal box is there, thin sheet metal box is there. There they are housed, and which is open at both the ends. And from both the ends, from the bottom from the bottom, the air is blown inside, either by fans, either by regulators. The air is being blown inside, okay. And so when the air is blown from the bottom to the top, the transformer gets cooled. The transformer gets cooled, and it is used for the rating more than 3 MVA, because till 3 MVA we can use air natural, but more than, if we want a larger transformer of more than 3 MVA, then we need to apply the air blast technique. We need to install air blast dry type transformer, okay. So this was all about the transformer, types of transformer according to the type of cooling. So according to the type of cooling, the main categories are oil filled and the dry type transformers. Then we have seen what is the oil type transformer. In the oil type transformer, again categorized as oil filled self cooled and oil filled water cooled. And the dry transformer, air natural transformers and air blast transformers. So this is all for today. In the next session, we will be dealing with the transformers, transformer types according to the structure. So according to the structure, they're divided into core type and the shell type. So we will be learning about the core type and the shell type transformers in the next lecture, and also we will be taking out some differentiable points between the core type and the shell type. So thank you. So please subscribe my channel, please share my videos, and if you have any doubt, you can ask me in the comment section. Thank you.